It's now 1 o'clock, so let's go ahead and get started. Before we do, I just want to make sure everybody is muted. Make sure to mute your lines so that will reduce our background noise. And Stephanie and Larry, I'm not sure which one of you is kicking it off.
Yeah, hi Marcella, I'm going to start. So are we ready to go?
Hi Larry. Yep, we are. It's all yours.
Okay, great. Okay. Well, hello everybody. Thank you for joining us today. We're going to be talking about statistical adjustment models and how they will be, how we developed it and provide you information about that process. I want to thank particularly Emily Eisenberg, who's one of our presenters who developed the model, and Stephanie Cronin, who will be our third presenter today, who will go over the tool. So I'm just going to start us off and let you know that this is the first in a series of webinars on the statistical adjustment model. You've been hearing about it, I know, for a couple of years now, and we've been working on it behind the scenes, and now we're finally at a point where we're going to start using it and explain it in more detail. The next webinar, this webinar will be just about the model, what it is, how it worked, and it will be showing you a tool in the end that we've developed that will have your state data and that you'll be getting soon, and will have your data for each state, for your particular state, so you can see how the model works with your data. So that we'll be talking about at the end. So that's what we'll be talking about today. Next week, you'll have a webinar with OCTAE about the performance target negotiation process, and that will be about that, and the models will be included in that discussion. And then the last in the series will be a joint webcast with partners, and it's going to include information about calculating performance at the end of the year, among other things. So this first one, we're just going to talk about the work AIR has done to develop the model, how it fits in the process, and again, this really nice tool I think you'll appreciate at the end. You will undoubtedly have several questions. We'd like to wait till the end to answer your questions. So what I'd ask you to do is write them in the chat box, or just keep track of them. So at the end of the presentation, we'll address your questions in the chat box, and I think we'll have an opportunity for you to verbally ask your questions as well. So let me start off with the next slide. Do I have control of that, Marcella? Can you advance the slide?
You're able to. You can use the arrows on the bottom left-hand side of your screen. Oh,
okay. Thank you. I see. Thank you. Okay, so first up, what is the statistical adjustment model? We're going to talk about what it is and why we're doing it. It's a model that's going to apply to your levels of performance, for the performance indicators, and it's required in WIOA in section 116. And what the model is a regression model, which is a statistical model that's very commonly used for situations and purposes like this, where you have a series of a set of variables, a set of data that you want to use to predict a particular outcome or performance. And we're using a regression model called a state fixed effects model. So what that means is, of course, there are certain variables we're going to really look at, listed here on the slide, like your economic conditions and characteristics of program participants. But there's also in your state, and every state is unique and has a set of characteristics that are usually unmeasurable or very difficult to measure. And these are things like your policies or your delivery system, and particular characteristics that are fixed over time, and fixed effects, they don't vary over the year, and they are related to your state environment generally. So that's what we use, that type of model. We've decided on this. And then there's another set of variables in the model. The sys effects are just kind of a big box that everything else goes into, and we don't really pay too much attention to it for the purposes here. But the things we are going to look at and are going to be important are the variables that are used to adjust performance. And these are the economic conditions in your state, such as your unemployment rate, percent of employment in various industries, for example, how many workers are in leisure and hospitality or manufacturing. Then there's also the whole set of characteristics of your participants that also might affect your performance. So these are demographic characteristics and including the barriers to employment that we've been talking about for a couple of years. And now you'll see, if you didn't know already, you'll see a real demonstration of why it's been so important and why we've been emphasizing the importance of collecting those variables, because they are part of the model as well. And those particular variables are the ones that are going to affect your adjustment or the adjustment that's made by the model. So the next slide, let me move to the next slide. We're looking at why are we using it. Well, what it does is it allows you a more accurate assessment of your performance of your state, given your state characteristics as measured in the fixed effects, and giving your characteristics of your participants. So it may give you credit for if you're serving harder to serve populations. In other words, your performance indicators will be adjusted for the characteristics of those hard to serve participants, or I suppose it could be the opposite as well. If you have fewer participants that are hard to serve, it might also adjust the other way. Also, they adjust for challenging economic conditions. So your unemployment rate, as I mentioned, is these economic measures are also in the regression model. It's going to compare your performance over time. What we did is we used your last 2 years of data, both participant characteristics and the outcome, the performance indicators for the last 2 years, and that was required in the model as well, that we have a couple of years of statistical stability or of data. Okay, so how are you going to use these? Beginning in the negotiations right now, starting next week, we'll be using them. They will be one of 4 factors for setting your targets. As I mentioned, there'll be a webinar next week, a week from today, on this process. We're not going to really go over it right now, but really it's now an additional factor in addition to the other factors you've always used in setting your targets. And it's going to help you set the target, help OCTAE and you jointly set the target for each indicator using the last 2 years of data. And because we need 2 years of good data, or relatively good data, it's going to be limited this year to MSG rate, second quarter employment, and median earnings. So you will apply the model. The model will be applied to those 3 indicators. Again, your student characteristics, economic characteristics, and then there's a fixed effect for state conditions. At the end of the year, we'll use that model again with your actual data that you collect over 2021. So the model right now is in the 2 prior years that helped create the model, that's used to make the adjustments, and then after you set the targets next year, at the end of the year, we'll be using it again to adjust the performance indicators. And as I said, this will be explained in more detail at the webinar next week with OCTAE. All right, so I'm going to turn this over now to Emily Eisenberg, who, as I mentioned, was the analyst who was primarily responsible for developing the model, and she's going to give you an overview of the process. So, Emily, are you ready?
On the model and how it will be used. Now we will get into more specifics about how the numbers used in negotiating targets are calculated and how the model will be used when program year 2020-21 data is available. As OCTAE described in Program Memorandum number 20-2, there are 6 steps in the process of using statistical adjustment models and applying the results. The first step is happening this spring during negotiations, and that first step shows up as step 1 on this slide here. The remaining steps occur once program year 2020-21 data become available. Steps 2 through 6 lead up to calculating individual indicator performance scores. Working backwards, the performance score is the actual level of performance for program year 2020-21 divided by the adjusted level of performance.
Is that
The
on
adjust.
mute? Mhm. So if I take a vacation,
I can hear somebody. Thank you. The adjusted level of performance used in calculating the performance scores is the negotiated level of performance for program year 2020-21 plus an adjustment factor. This is shown as step 3 on this slide. The adjustment factor is the predicted program year 2021 performance minus the predicted base year performance. The adjustment factor essentially accounts for any changes in participant characteristics or economic conditions between when targets were negotiated and program year 2020-21. The adjustment factor is shown as step number 2 on this slide. The vocabulary shown on this slide will help us understand the calculations in more detail. Predictor variables are the state characteristics and economic conditions in a particular year, such as the percentage of participants in a state with disabilities. In our model, most of our predictor variables are usually percentages of people in certain groups. And then, as Larry mentioned, we also have some economic condition variables, such as the state unemployment rate. That would be another predictor variable.
Emily, I'm sorry to interrupt. Do you mind speaking up just a little bit?
Oh, okay. Maybe I can move closer to my
Oh, perfect. Yes. Thank you.
Okay. Okay, great. A coefficient. Now we'll move on to the next vocabulary word here. A coefficient is a statistic produced by the model that reflects the rate of change in the performance indicator, such as percentage of participants with disabilities or state unemployment rate, given a unit change in a predictor variable. I'm sorry, the performance indicator would be an outcome such as the measurable skill gains rate, and the predictor variable would be, for example, the percentage of participants in the state with disabilities. And the state fixed effect represents anything unique to the state that is constant over time and cannot be directly measured by observable characteristics. These concepts sound a little abstract, but we'll provide concrete examples in the next few slides. Now we'll talk through the first step, predicting performance to inform target setting for program year 2020-21. This is what's going on currently this spring. For negotiating targets for program year 2020-21, we calculate predicted performance based on state characteristics from the most recent year of data available. Predicted performance is based on coefficients from a model with at least 2 years of prior data for each indicator. For example, program year 2017-2018 and program year 2018-2019, and state characteristics from a particular year. We're calling predicted performance based on the most recent year of data available, estimate 0. You can see that in italics on the slide here, and we're going to be referencing that estimate 0 on future slides as well. The statistical model applies to the measurable skill gains rate, the second quarter retained employment rate, and median earnings. Eventually, the model will be applied to all 5 indicators. The most recent year of data available is a proxy for program year 2020-21 state characteristics, since that data is not yet available. The models and coefficients used are going to be the same for all states. We'll show an example formula for estimate 0 on the next slide. Later in the webinar, we're going to preview a tool to show you how numbers are calculated at each step in the process. Here we present an example of calculating estimate 0 using a simplified model. Each indicator's predicted value is equal to the sum of products of each predictor variable in the model. For example, the percentage of participants aged 25 to 44 times its coefficient in the model, where the coefficient represents the rate of change in the indicator given a unit change in the predictor. The state fixed effects or other state context is then added to that sum. For example, in a simplified version of the model, let's say we're predicting measurable skill gains rate based on the percentage of participants in each age category. In this example, our estimate 0 is equal to the percentage of participants aged 19 to 24 in a particular state year times the coefficient for that age group, which is the same for all states based on the model, plus the percentage of participants aged 25 to 44 times the coefficient for that group from the model, plus the percentage of participants aged 45 and older times the coefficient for that group, plus the state fixed effect. In this example, the sum of the products plus the state fixed effect yields a predicted measurable skill gains rate of 59%. Again, when we use the state characteristics from the base year, we're calling that estimate 0. Once program year 2020-21 data is available, we start the steps towards calculating the individual indicator performance scores. Step 2 is calculating the adjustment factor. Recall that the adjustment factor essentially accounts for any changes in state characteristics between the base year used in negotiations, which is the most recent year of data available now, and program year 2020-21. First we calculate the predicted program year 2021 performance levels using program year 2020-21 state characteristics and the same model that we used for the base year predictions. We're calling program year 2020-21 predicted performance estimate 1. The models are the same for both program year 2020-21 predicted performance and program year baseline program year performance. However, the values of the state characteristics change between the base year predicted, those used to predict the base year predictions, and those used to predict program year 2021 performance levels. The adjustment factor is calculated as predicted performance using program year 2021 state characteristics, which we're calling estimate 1, minus predicted performance using base year characteristics, which we're calling estimate 0.
And Emily, I don't know if you saw Adam's question about whether you were talking about an year-end performance adjustment on that last slide.
I'm talking about the adjustments with program year 2020-21 data. Maybe I think Stephanie can talk about this more at the end. I believe that there's a gap that 2019-2020 is sort of a gap year, but I'm going to let Stephanie talk more about that. After we have the adjustment factor, we can calculate the adjusted level of performance, which is step 3. The adjusted level of performance is the adjustment factor, which is estimate 1 minus estimate 0, added to the negotiated level of performance for program year 2020-21 for each indicator. So again, estimate 1 is based on program year 2020-21 state characteristics, and estimate 0 is based on baseline state characteristics, which is the most recent year of data we have available now. And then that difference is added to the program year 2020 negotiated levels of performance. With the adjusted levels of performance, we can calculate the indicator performance scores and then the overall state score. The individual indicator performance scores are calculated as the actual level of performance in program year 2020-21 divided by the adjusted level of performance, which we talked about on the last slide. This produces a percentage measure. The overall state performance score is the average of the individual indicator scores. So for the next round, the overall state performance score will be an average of the individual indicator scores for measurable skill gains, second quarter employment, and median earnings. This will be explained further in the Department of Education webcast that Larry talked about at the beginning. And OCTAE Program Memorandum number 20-2 also provides additional details. Now I'm going to turn this over to Stephanie, who will make this more concrete with our statistical adjustment model tool.
All right. Now we know that this is a lot of technical information and it's going to be new to most of you. But OCTAE and AIR will be providing support and you'll have opportunities to get more comfortable with it. The first support that we're going to provide is an Excel-based tool that walks you through the calculations made during the steps of the statistical adjustment modeling process. We've also included some graphics in the tool that illustrate the relationship between the predictor variables, which are your state characteristics, and your performance indicators. And as you'll see, some of these characteristics are more important than others in predicting performance, which I think will be interesting to all of us. Next week, Monday, we'll send each of you a copy of the tool that's populated with your own data. But note that the data for the out years, like 2020, are proxies at this stage, obviously. Those data will be replaced with actual data once 2020 indicator data become available. So let's take a look at a version of the tool we created that includes hypothetical data. So the first tab in this tool provides access to a mini tutorial about the process, which is basically a refresher of what you have just heard from Larry and Emily. Next is a tab for the negotiations estimate calculations, that estimate 0, which is step 1 in the process. And as you can see here, we take the value for each state on the predictor variables, over here in this first column, the state characteristics, and multiply that by the coefficient that was generated for that variable by the fixed effects regression model for each indicator. Remember from earlier that a coefficient represents the rate of change expected in a performance indicator like MSG, given a unit change in a predictor variable like the percent of participants with disabilities. This product gives us the effect for each predictor, which are the values we use in a bar chart on the next tab I'm going to show you. I should point out that this tool does not show you the regression models that we use to get these coefficients. Those models include data from all states and were run in a specialized statistical software. But anyone like Adam who wants to learn more about the regression models can talk to us offline and we'll give you all the details you want. All right, now, this shows the bottom of that same tab. There is a long list of state characteristics that go into this model. The products of the predictors, the state characteristics, and their respective coefficients are summed up in that third column of numbers you see that's in bold and added to other statistics at the bottom there, like the state-specific effect, the fixed effect, from the regression model that represents characteristics like state policy that are not captured by the other predictors. This sum gives us an estimate for each indicator. The value on the bottom row is the estimate that will be used as one of the 4 factors to inform target setting during negotiations. So what you care about here is that bottom row that's in dark blue. In this example, it's 46.1% for MSG. And that is what we've been calling estimate 0. And we'll do that for each of the performance indicators. The next tab provides visualization charts for the effects calculated on the previous tab. In the first column, again, you see the predictors, the state characteristics, and the values in the second column that are used in the regression models. Those are the values that will differ for each state, these percentages. The 3 big bar charts represent the relationship between each of the state characteristics and the performance indicators. For example, in this case, you can see that the percent of participants who are male does not seem to be a very strong predictor of any of the indicators, but the percent of participants who are 25 to 44 years old is. So this is the kind of thing that we'll all be able to look at, looking at your own state data, just to see what are those values on the characteristics in the model, and what do those seem to be contributing to the predicted performance estimates. All right, and then we have a tab for negotiated targets, which of course right now is just full of proxy values, but we will fill those in once the targets are final. And we've included those in this tool because they're used for calculations in other tabs. Next, we have a tab for the adjustment estimate calculations in step 2. That's estimate 1. The actual 2020 indicator re-estimates and adjustments can't be made until we have the indicator data for 2020. But once we have it, the actual values in this tab will be updated. For now, these numbers are set to equal the numbers in the negotiations estimate tab, so it's the same data. The model coefficients from the negotiations regression model will remain the same in the 2020 model. That's the second column of numbers here. But the product of the predictors, the state characteristics, and their coefficients will change. That's the third column of numbers there. Wherever the values of the state characteristics change. So as things like the distribution across the age group changes and the other characteristics, the effects of those characteristics will change somewhat as well. And once we have 2020 indicator data, we'll again calculate an estimate for each indicator, like the 46.1 for MSGs that we calculated earlier, that will be used to adjust your 2020 performance targets in step 3. So here's the adjustment model visualization chart. Currently, it matches what's in the earlier visualization chart because we don't have 2020 data yet. But once we do, the example values column will be replaced with your 2020 data. Now in the steps 2B and 3 tab, the adjustment factor and adjusted level of performance is calculated for each indicator. First, the adjustment factor for each indicator is calculated as the re-estimated level of performance, that's the estimate 1 you see in the second column of numbers, minus the predicted estimate, the estimate 0 in the first column of numbers. This may be a positive or a negative number, or in this case, it's 0. Second, we sum that adjustment factor and the negotiated level of performance, which we've pulled in here from that earlier tab, to get the adjusted level of performance. That's in the last column. In this case, we're using an example where the estimates from negotiations and adjustment steps are equal. So the adjustment factor is 0. In reality, there will probably always be at least some amount of adjustment. It might be small, but there will be some. In steps 4 to 6 tab, you'll see how the indicator and overall performance scores are calculated. Once we have the adjusted level of performance for each indicator, we can calculate scores for each indicator and the overall state performance score. Indicator performance scores are calculated as the actual level of performance from 2020 divided by the adjusted level of performance we've calculated. The overall score is a simple average of those 3 scores. In this case, a happy scenario, all scores were 100%, so success. And you'll see we have over on the right side here a bar chart just showing you the indicator scores set against the criteria of 90%. All right, so other upcoming activity, as Larry said, next week you'll be getting a lot of material. You'll be getting your workbook from OCTAE on Monday. And from us, you'll be getting the populated tool for your state. And then next Thursday is the OCTAE webinar for performance negotiations at 1 o'clock. And if that hasn't been sent out yet, it will be sent out soon. So please reserve that time. And then for the May annual state director meeting, AIR will hold a session to provide more opportunities to interact with the model tool, and you'll get a more interactive version of the tool we're working on that allows you to change some of the values within the tool and do some scenario planning. So you can change your state characteristics to some extent and see how that impacts your performance scores. So I think that that'll be interesting for people. All right, and with that, I think we're going to move to questions. Marcella, are there any questions that we need to take care of from chat before we open it up?
No, the only question Cheryl already answered. It was regarding whether or not information had already been sent out about next week's webinar, and she explained that that has not, but asks that everybody holds March 19th at 1 p.m.
Okay. All right, yes. Okay, any other questions or comments? You can either unmute yourself or type it in the chat.
So we had a question from Brian. I don't know if you can read it yourself or if you want me to.
Oh yeah, good question, Brian. I'll let Emily take that one. I think some of them are and some of them aren't.
Oh, sorry, Emily, you're muted. Let me unmute you. There you go.
Oh, okay, great. Can people hear me now?
Yes.
Yes.
Okay. I believe that most of the coefficients were not statistically significant because we don't really have much data this year. We have 2 years of data, which is not really a lot of data, and I can double check the coefficients, but my recollection is that most of them were not statistically significant.
Yeah, so Brian was asking if the coefficients from the national regression model were statistically significant. And Emily's saying that we don't have much statistical power yet because we only have 2 years of data. But as the years go on, we'll be able to include more and more years of historical data. And so we'll have more power.
Yeah, and our data is all, Brian, also, I don't know if this was apparent or not, but all of our data is state year level, so that means that each observation is a state year, so we end up with, for our models with 2 years of data, that gives us 104 observations, which is really just not all that much. So yeah, as Stephanie said, I think we might get different results when we have more years of data.
Okay, and Terry has asked if you guys can get a copy of the PowerPoint, and unless Cheryl disagrees, I don't see any reason why we can't send that out. And Venu asks if the coefficients for MSG and employment second quarter are based on different years. No, they're based, well, yes and no. They're based on the same year of outcomes data, but because employment is a follow-up outcome, the student characteristics come from the previous year. So that's a good question. And in the tool,
Yeah.
you'll see that we've marked it pretty clearly which years the data come from. And Diane asked, where is the data that is used to calculate the economic conditions? Okay, Emily's about to answer that.
Yeah, that data is data from the Bureau of Labor Statistics, and we have quarterly unemployment rate data for the states, which is from their unemployment rate. I forget it. Bureau of Labor Statistics produces quarterly state unemployment rate data that we used, and then we took the quarterly data and we converted that to program years. We matched up the quarters that would be in each program year and essentially averaged the state unemployment rates over the quarters for that program year and used that as our unemployment rate in the regressions. And then in addition to the unemployment rate, we had measures of the percentage employed in different industry sectors. And that data is also from the Bureau of Labor Statistics and is also quarterly data. And again, we averaged that quarterly data over the quarters in the program year to have a program year measure that we included in the regressions.
Okay, and then Venu asks, when the 2020-2021 data are ready, will we distribute an updated version of the tool? Yes, of course we will do that. All right. Any others?
Looks like Adam is typing.
Okay, so while people are putting in their questions, I wanted to make another plug for our session at the state directors meeting. I think it's May 6th, or no, May 5th. And we are creating a slightly different version of the tool that has more functionality. And I think it will be, I mean, as fun as this kind of thing can be, I think it'll be pretty interesting for people to be able to play with the numbers. And we can share that version of the tool with other states if they want it to. Okay, Adam. Question on the unemployment and economic data. Why are you using the values from the exit period and not the second quarter period? Economy in second quarter is more relevant than exit. I cannot answer that question because I only partially understand what you're asking.
I think I understand. Let me make sure I'm understanding, and then, or is somebody else going to have a response?
No, I was just going to clarify. This is Adam. So what I mean is, if we're measuring if the measure in question is the percent employed in quarter two after exit, then what is relevant to determining what percentage of those people should be employed is what was the state of the economy in quarter two post exit, not what was the state of the economy a week ago, or I mean 2 quarters ago at exit. And I'm going to use a really big example. The price of oil in just dropped by a third or thereabouts over the last few days, right? So if for my people who exited in December, their quarter two is going to be April through June, when oil jobs are going to be down, and that's going to have big ripple effects in the economy in terms of the unemployment rate and whatnot. So that's why I was asking the question.
Oh yeah, this is the same question I asked earlier. But basically, we have to follow the same approach as our partners at Department of Labor. And so, Emily, you can correct me if I'm wrong, but this is the approach that they take.
Okay, I'll chat with them. Thanks.
Yeah, Stephanie, that's correct. This was the approach used by the Department of Labor, and we're trying to be consistent across departments. But yes, Adam, that's a fair question. We could also, I mean, us at AIR could also just do checks and see how that affects the model. I mean, we have all the data, on our computers, and we could check and see if that led to different results, even though we have a current model being consistent with DOL.
Larry, I think I already answered Venu's question that the outcomes data, the indicator data, come from the same year. And Brian asked.
Okay, can you? Okay.
Brian asked if there's a way to determine when running the regression model for estimate 1 whether or not a specific predictor was more strongly related to the change in performance. And well, I think we can, yeah.
You want
Stephanie, did you have a response?
I think we can look at the effects across the 2 years and see how they change, but is there a better way to do that?
Well, we can also look at the, well, there's sort of 2 ways to look at it. One is the magnitude of the coefficient, and coefficients that are larger numbers are a stronger predictor of the outcome. And then there's also statistical significance. But as we said, most of our variables weren't statistically significant. But you can look, even though it's not across the cutoff to be statistically significant, you can still look at whether some are closer to being statistically significant than others.
And Emily, we should probably point out that while because we have such low statistical power right now, the individual predictors aren't significant, but the model itself seems to be doing a good job of predicting the indicators as a set.
Yes, that's correct. The predicted values that you'll see from OCTAE next week are in general across the board very close to the reported outcomes. So the model with our current predictors and the unobserved state factor yields predictions that are pretty close to what is reported. And that's right now the predictions are based on reported outcomes for the same year that is used to calculate the model. So we'll have to do some checks when we try using the model with data that wasn't used to calculate the model, which would be the case with program year 2021 data. But our current predictions are really quite close to the reported values.
All right, any other questions?
I'm not sure if you quite answered whether the tool will do just that you were just talking about.
In a sense, I mean, you can eyeball it. We're not, the tool won't have sort of like a statistic about the change between the years, but you can look at it and you can see the shifts. And with the next version of the tool we're creating, you can actually play with the numbers and see if you know that your participants are shifting somewhat and you want to edit the characteristics data to demonstrate that and kind of predict on your own what's going to happen, you can do that and see how it'll change.
Yeah, right, Stephanie. And you can also do that with estimate one by, looking at that chart that we had that shows how the contribution to each indicator when you put in the estimate one data. The dashboard chart.
And don't be afraid to reach out if you have questions or you just want more information. We know that this is a lot to take in and it's important, so we're here to help.
Stephanie, there's no adjustment when there's 2019-2020 data. Is that correct? We're waiting for the following year of data?
That's right, yeah. Mm-hmm. It's going to be a while. So you have plenty of time to take this all in. Okay.
So it looks like there are no more questions.
We look forward to seeing everyone at the State Directors meeting, and we will talk to you soon.
Oh, and Stephanie, everyone, can you hear me?
Yeah.
We're going to put the recording of this webinar and the PowerPoint slides on the website by tomorrow or Monday, so you can access it there. And there's several people have asked for it. If you want it more quickly, just email one of us and we'll send it to you. Okay, thanks. Thanks for listening, everybody.
Yep, thanks, everyone.
Thank you.
Bye. Bye.
Bye. Bye.
Bye-bye.